Power reducing at half angle identities. The double angle identities that we've learned allow us to derive some other advanced trig identities. The first group is called the power reducing identities. And these are very easy to come by. For example, if you take the first version of the cosine double angle identity, which says cosine 2 theta equals 2 times cosine squared theta minus 1, all you have to do to obtain the corresponding power reducing identity is isolate this cosine squared theta. Just get that by itself. I can do that in a couple of steps. I can add 1 to both sides. So I have cosine 2 theta plus 1 equals 2 times cosine squared theta, and then just divide both sides by 2. And I now have cosine squared theta equals, on the top, cosine 2 theta plus 1, on the bottom 2. Well, that is this one right here. The numerator is written around the other direction, but it's the same thing. The power reducing identity for cosine squared theta. If you did the same type of calculation with this double angle identity for cosine, you'd obtain this power reducing identity. The tangent one is easy enough to obtain from these first two. Tangent squared would be sine squared over cosine squared, so just divide these first two and you'll get this. What are the power reducing identities used for? Well, the name kind of gives it away. The left side of each of these identities has an exponent. But if you notice, the right sides do not have exponents, and that's the point. In calculus, there are times where you want to get rid of an exponent on a trig function, and these three identities allow you to do that. Well, let's take a look, secondly, at what are called the half angle identities. Once again, these identities, these new identities, can be obtained from our double angle identities. The half angle identities talk about the relationship between the sine or cosine or tangent of half the measure of an angle and the sine or cosine ratios of the original angle. So you can see, for example, in this first one, if I have an angle theta and I know the cosine ratio of that angle, I'm able to find the sine ratio of the half angle, theta divided by 2. Here's one for cosine of the half angle. Notice there are 3 different versions for the half angle identity for tangent, and in any given situation you would just pick the one that seems to fit your situation the best. Well, where do all these identities come from? Well, let's see if I can derive one of these identities. Take a look at this double angle identity for cosine. It's the third one. I'm going to make a substitution here. I'm going to say that angle 2 theta is called alpha. So I'm going to replace everywhere I see a 2 theta with alpha. Let's see what would happen. I would now have cosine alpha, because 2 theta is equal to alpha, equals 1 minus 2 sine squared, and then let's see, theta. Well, if 2 theta is equal to alpha, just divide both sides by 2 here, you would have theta equals alpha over 2. So I'll replace this theta with alpha over 2. This should make good sense. This is a double angle identity here, and so we know that this angle is always twice as much as this angle, and that's still true. Twice as much as alpha over 2 is just alpha. Well, let's solve for sine alpha over 2. One thing I think that might help me in the solving process, let's remember what's actually being squared here. It's the entire ratio. So sine alpha over 2, that whole thing is what's being squared. Let me write it this way just for the sake of the algebra. So let's see, how could I get that sine alpha over 2 by itself? I would have to subtract 1 from both sides. And then it looks like I'll need to divide both sides by negative 2. Let's see, so on the right, of course, the negative 2's cancel. On the left, I don't really want to have a negative on the bottom, so I think while I'm cleaning this up, I'm going to multiply the top and bottom by negative 1. And so what do I have now? On the top, I have, after I distribute, negative cosine alpha and plus 1. I'm going to write that in the opposite order, so I'm going to put the plus 1 at the front and then minus cosine alpha. I have a positive 2 on the bottom. The only thing left on the right side is that trig ratio being squared. Well, that's the last thing I need to get rid of, is that squared, which of course I can do by simply square rooting each side. When I do that, I get a plus or minus. And if you look carefully here, all I have left is sine alpha over 2 on one side. I'm going to move that to the left side. And then on the other side, I have that plus or minus thing with the big square root. Well, we have just derived the half angle identity for the sine function. Here it is right here. Now it's being expressed here using theta. You could use any letter you wanted, but if you compare, you'll see we got exactly the same thing here. The plus or minus does make things a little bit tricky in the identity. It doesn't mean that there are two answers. It means that you have to choose which it should be based on the quadrant that you find yourself in. So you have to know, well, what quadrant is my alpha over 2 angle in? And then you can choose the right sign. The other half angle identities can be similarly derived from the double angle identities. We'll focus our attention on how to use all of these new identities. Thanks for watching.